Hey everyone! Today, we're not just going to talk about coding, we're going to jump right in and build our very first interactive quiz. And we'll be using this amazing tool called Scratch, which basically turns the basics of programming into a super fun, creative game. You ever play a game and think to yourself, man, I wish I could make something cool like that? Well, what if I told you you're actually just a few simple, logical steps away from doing exactly that? Let's check it out. So, to make anything happen on a computer, you've got to speak its language. And that language is code. At its heart, code is really just a set of step-by-step instructions. It's like a recipe that tells the computer exactly what you want it to do. And this is why Scratch is so brilliant. Instead of typing out a bunch of complicated commands, you use these colorful code blocks. They work just like puzzle pieces. You can literally just drag them, drop them, and snap them together to build your set of instructions. It's that easy. Okay, so before we start coding, we need to get to know our creative space. The best way to think of it is like a theater. Every show needs a stage, and of course, it needs a star performer. First up is the stage. This is your digital canvas, It's the background where all the action of your project is going to unfold. And on that stage is our main actor, the sprite. A sprite is any character or object that you give commands to. It's the hero of our story that's going to move and speak and interact based on the code that we build. So we've got our stage and our sprite. But how do we actually tell our sprite what to do? Well, let's take a look at the instructions. It all comes down to those color-coded blocks. The blue ones, those are the motion blocks, and they're all about, well, movement. They control where the sprite is, which direction it's pointing, and how it gets from point A to point B. Then you have the purple looks blocks. These control everything visual about your sprite. You can use them to switch its appearance, maybe change its size, or even make it talk with speech and thought bubbles. Now to add another layer of life to it, you've got the magenta sound blocks. These let you play sound effects or music, adding an audio dimension that can perfectly match the action on the screen. But how does the code know when to start? That's the super important job of the yellow events blocks. These are the triggers. They tell your code to run when something specific happens, like when you click the big green flag or press a key on your keyboard. Okay, we've met the key players. Now let's put them to work and build something that can actually respond to a user. We're going to make a simple interactive quiz. So for our program, building a quiz means it needs to do two fundamental things. First, it has to ask a question, and second, it has to check if the user's answer is correct. Simple enough, right? But hold on. Think about this for a second. When a user types in an answer, how does the computer remember what they typed so it can check it? I mean, where does that information get stored? The answer is a really powerful concept called a variable. The best way to think of a variable is just as a container, like a little storage box. You can put information inside it, a number, a word, whatever, and the computer will just hold onto it for you. So in our quiz, that variable is where we'll store the user's typed answer. Once we have their response safely tucked away in that container, we can then open it up later to see if it matches the right answer. So here's the logic for how our quiz will work, using three new types of blocks. First, we use a light blue sensing block to capture the user's answer. Second, a green operator block compares their answer to the correct one. And finally, an orange control block decides what to do based on that comparison. This whole thing is called a conditional statement, a simple if-then-else decision. The program checks a condition. If the user's answer is correct, the condition is true and our sprite says correct. But if it's anything else, the condition is false and the sprite says try again. This simple logic, this is how pretty much all computer programs make decisions. And believe it or not, just by understanding that logic, you've learned to think like a coder. Seriously, what we just did is based on a core principle that drives all programming. And that principle is just one word: decompose. We didn't try to build the entire quiz all at once, did we? No way. We broke the big problem down into smaller, manageable parts. Ask a question, get the user's answer, store it, compare it, and then respond. That process of breaking down a complex problem is the absolute essence of coding. The best thing you can do now is just tinker. The real magic happens when you start dragging blocks around just to see what they do. Explore, play, and discover what's possible for yourself. So you've seen how to turn a big idea into small, logical steps. You now have the fundamental building blocks to create. The only question left is, what will you build next?